Hello everyone. I'm Ajith Raghavan, and I'm here to present my work on machine learning, the donor journey, along with Dr. Greg Lee. Most of the work was done while I was master student in Georgia School of Computer Science and an intern with FunMetric. But we'll also be presenting some new results today as well. So since we don't have a lot of time, we'll just try to keep it on high level. And we'll first define what the donor journey is, and then we'll talk about the steps needed to set up the machine learning problem of predicting the outcome of particular donor journeys. We'll also talk about what we can do to actually help charities with this learning. After we talk about our problem, we will also talk about the solution and how well the solution works, meaning how accurately can we predict how much a constituent will donate based on their individual donor journey. Being able to treat constituents differently based on their individual preferences is at the core of data-driven fundraising. And finally, Dr. Greg Lee will talk about where this research is going. We want to take our learned lessons and apply them to specific types of giving, such as measure gifts and plan gifts. Donor journey. The donor journey is the content and medium of communication that a donor engages before making a donation or before making a gift. We focus on electronic communication as even before the COVID pandemic, especially because the charities are moving towards email campaigns, and also the email campaigns are more cost effective. The examples of this type of actions are delivery and opening of emails, or clicking on email links, visiting charities donation portals, which and also there are a few negative actions such as unsubscribed and bounced emails, which of course we want to avoid. To be clear, we want to learn what makes for a successful donor journey in general to try to replicate this, but of course the donor journeys are not one size fits all. So some people want to receive regular emails about a charity, while others would prefer mostly to be left alone. On the other side, it's difficult to communicate differently with single constituent. So the goal is to learn what type of which types of people should be guided on what type of journeys. Sample journey actions can, as seen here, are receiving an email, which constituent has to be sent an email, and once they receive an email, they open it, and this is generally the only action which is controlled by the charities. And the next one is opening an email. Constituent opens an email, and they have to, if they did not open an email, they have to be left alone, and we do not send them more and more emails. And the next one would be blocking an email, which clearly says it's a negative action which we should be avoiding. And finally, visiting a donation portal. Generally, this is the last step before a donation is made. When a constituent gets to this point but does not donate, we want to learn what push they need to do so that they can possibly make a donation. And what can we do? As mentioned in this donor journey setup, we can only send email. We can choose when to do so, but also what should that email look like. Should the email be plain text, or should it be smaller? Should it be long? Should it be full of images, long? Or so these are the email parameters we'll refer to that we can alter, such as the links, images, paragraphs, and number of words. We first need to model the donor journey. Once we have an accurate model, we can query that model and say, what if we sent an email? We sent a constituent a shorter email full of pictures, and does that make the constituent make a donation? If so, how much would they donate? If the model is not accurate, we do not really care what the response is. But if it's accurate, we can use it to tailor emails to particular groups to give them a more pleasant experience with the charity. The data. So the donor journeys are chronologically ordered. Actions are related to each other by time. Someone who opened an email and then visited the donation portal is not in the same position as someone who visited donation portal and then they opened an email. So we approached the donor journey problem as a time series data problem, which is why we use the recurrent neural networks such as neural networks such as recurrent neural networks, convolutional neural networks, as they deal with the past data, and then they use the data to predict what the constraint is going to do next. So what are the complications that we face? So how far should we look when setting up this problem? As there are few factors that we should consider. As I mentioned, the first point: how many past actions of a constituent or charity that should be considered? Should we look back at only one last action, or should we look back at maximum number of actions, such as like 35 or 45 or 100 number of actions? So maybe somewhere between, or we also experimented with different window sizes. And the next complication is, could we learn across charities? What if we combine the data across charities, and is that going to help a charity with less number of data? And the next one is, what features of an email should we experiment with? Like, number of words and paragraphs seems obvious, but what about how the email is laid out, which corresponds to either HTML blocks or images or some combination of both? We consider 8 email features in our work. So based on we took all those problems, and we modeled the machine learning. We use the machine learning algorithms to model the donor journey. And how well can we do it? Is, on a wildlife charity, we reduce the MAE from $25 to $16 on a wildlife charity. And on University Foundation, we reduced the error percentage to $25 from $50. The results. So yeah, to summarize the results, the model shows that, okay, we need at least 6 actions so that the error percentage would be really low, and the model would be accurate. And merging or combining data does help, especially for smaller charities. And smaller emails or shorter emails for veteran donors, and longer emails for the new donor should be sent. As seen in the results page here, we also added constituent features to the data, and except for the yellow bars, all the others have reduced the error percentage. The yellow bar is the data with lower number of samples. And merging data results, which is like combining data across charities, but here we only try to combine data of the same category. As seen, C1 and C2, the error percentage has been increased, but whereas the third and fourth bar graphs, C2 data alone or C2 with C1, the error percentage reduced from 195 to 170, which clearly says that merging data of in the same category does help sometimes, and sometimes it does not. We also took that experiment, and then we tried to combine all the charities irrelevant to what category they fall into. In the first figure is the University Foundation, where you can see the error percentage has been dropped in most cases, except for using one or two machine learning algorithms, where the error percentage has been dropped from $48 to $28. And in the figure 2, the error percentage has been dropped from $480 to $77, which is like major improvement, which clearly says that combining the data does help. And the email parameter results. This graph shows the mode and mean of the number of words, paragraphs, and all the email parameters predicted by the machine learning algorithms, which says that we should send shorter emails, the emails with shorter number of words and paragraphs to the constituents. And the final slide will be talked by Dr. Greggy.
I'll close it out. Yeah, so Ajith did an awful lot of work that taught us some lessons about the lower levels of giving. And for those of you who were at the talk Russell James gave this morning, that's part of why I was asking him about these donor journeys, because they're not the same, right? You're not generally getting a huge gift by sending 2 emails to somebody who would give that gift. So the next step in this research is, what is the major giving journey? What do we need to do to help people who actually want to give to the charity? This is all, people who care about that particular cause. What can we do to facilitate that? I mean, major gift officers know a lot about that, but what can we learn with AI that could help, right? This is always a tool to help. And similarly, but not that similar, on the plan giving journey, and Russell taught us some lessons about that too, right? When to actually start talking to people and when to not stop talking to them, which was one of the bigger lessons from today. So we're going to take all of this machine learning that all these algorithms that Ajith had used and try to apply them to this. Now, I actually noticed Colin Conrad said in the chat there that how much data do you need, right? And the biggest issue with major giving is not a ton of data. There aren't that many major gifts. And that's where just on the combination, that's always anonymously done. Can we learn any lessons across charities? So that's where we're going next. With that, we're all done and happy to take questions. So yeah, I didn't see Colin Conrad's full point there. So how much data is enough, right? And I mean, to Rachel's point, Rachel Crosby's point earlier, it's, the best time to plant a tree is now, like just get going. We're talking in the thousands of data points to give a broad figure. If you're capable of working with other organizations and just sharing that data anonymously, that's another lesson we're learning about, across similar verticals. Do people give? There's lots of research into people give to universities for the same reasons and not for the same reasons that they give to a disease charity. So if you can get a hold of that, you can augment your data. But a data collection is the other part, right? Just get more data points. You can't model on if somebody read your email if you don't collect that data. So that would be my lesson there. I do see a question about a link to the research paper. We'll certainly provide that as well.